Yes, hello friends. So we can try to solve this equation by using linear least square method. So we approximate the solution. Why we approximate the solution is due to number of rows is greater to number of column. As you see here, we have 3 rows, but we have 2 columns. So using least square method, we have theorem 1. Theorem 1 stated that if A be a matrix of dimensional mn, where B is a vector, so this linear system is transformed to A x equal B, where A is a matrix of coefficient, x is vector of x's we are finding. So the solution will be A transposed times A k inverse, so times A transposed times B. So step 1, due to this equation as an usual does not have a solution, so we use this linear least square method to approximate the solution. So step 1, let us compute A transposed times a matrix A. And then after we compute a vector A transposed times B. Next step, we form augmented matrix for equations, where we will write A transpose times A times column vector, then equal to A transpose times B. So we can use the method for reducing by Gaussian, or we can use also inverse as we have said here. Okay. The next step 3, the solution of x column will be to as the solution we are finding. So we write this one, A times x's is approximately equal to B. So equal sign cannot afford this, so that's why we use approximation. So step by step we can solve this. So we write this as augmented, so where A is coefficient of x's, then 0, 1, 2, 0, 1, 2, 2, -1 and 0. It's this one. So, and B is column vector. It's the solution. 1, 0, and -1. You see here? So, as you see, dimension of this matrix A is M times N, where it is a 3 times 2. So, M is greater than N, so we will use least square method. So this square method minimizes the square Euclidean norm of residue vector where R equal B minus AX. So this minimum for Euclidean norm vector, we'll see this formula later. So this is very important because it minimizes the distance. Distance from vector B to vector AX approximated will be less than or equal to distance from vector B up to vector AX as an usual. So we can discuss this later. So let us step by step we compute this. So then we have a matrix A and we have also vector B. Step 1, as we said, it is the A transposed times the A times the column vector X we are finding. So also equal to A transposed times B. So A transposed, we remember, column become a row. Column become a row. Okay. So first of all, you compute A transpose times B times a matrix A, which is equal to this times this one. We'll have this matrix 2 times 2. Next, we compute a vector A transpose times B. We'll get this vector, column vector. Next, we write as augmented matrix. It is this one, A transpose times A. This one, as we have found here. So times the X, okay, X is here also. So equal to A transposed times B. A transpose times B is here. Its answer is here. So then you write this one. So X, as we are finding, can be A transposed, this one, times the solution as inverse method. Also, we can use elimination method, easiest way. It is this matrix times x1, x2, which is equals the solution. So by changing it to in x's, this one times this one plus this times this one equal this, as we are making a linear system here as the system of equations. By using elimination, next after we will get this solution as x1. By replacing in equation 1, okay, we will have x2, which is equal to negative 1 over 3. So next after this x, we have 1 over 3 and negative 1 over 3. So A matrix times the x approximated is also approximated equal to B. So the next, we can calculate the Euclidean normal vector, as we said before, to minimize the distance. So which is equal to B minus A x with norm 2. Remember, Euclidean normal vector use norm 2. So first of all, you can compute B minus AX, which is equal to this one. Okay. First of all, you can compute AX. By multiplication, we have this column vector. Okay. Next, we compute B minus AX. Its solution is this one. Okay. By using norm 2 by Euclidean, we will find x squared plus y squared plus z squared, then after square root. So we will compute this one to get root 6 over 3. So it means the distance from B up to AX approximated will be less than distance from B to AX, because this x is not known. Okay, so you can use this as approximated. Okay, so solution of this square x1 is equal to 1 over 3, x2 is equal to negative 1 over 3. Okay, thank you for watching. Remember to subscribe my channel and also share this video to many people. Goodbye. I love you so much.